Welcome to all to class number 58 of our course SFD and BMD. Last class I told you same question will be once again considered. Last class this load was 30 kilonewtons. See, at that time your shearing force diagram came, it crossed the baseline here. Therefore, you have to locate that point and find BM there also. This is already over in class number 57. Now, then only I told, next class I will change that load around 65, 70, 75 I told. I calculated little less than 70 is sufficient, so I decided 75 is better. So I made the load 75. All other data remains same. The very purpose is simple. I want SFD to come this way, and then come up to here, then cross the baseline here. These all principles already told for you. But practice purpose, it is important. So, more examples I wrote. So, it's the question. Words I am not giving. Words already told last time. Same words where I told last time 30, change it to 75. Okay. Now, new question. Solution, calculation of support reactions. Let VA and VB, yes, you know what to write. I have been telling this one from beginning of the class course. Take moment about A. Minus VB into 10, actually first of all this is also not required. Plus 90 into 8, 75 into 6, 60 into 3, 12 into 6 into half of 6 equal to 0. I might have told some other way. Anyway, see, maintained. We get VB, sigma V 0. You simplify and get the value of VA. You get the support reactions. Now we will go for SFD and BMD. Okay, now ready for SFD BMD. I told you last time. See, 156.6 kilonewton. Shear force calculation. Last time I told, in future I am not going to write it if it is the same as earlier, unless some changes are there. If any major, any even minor change is there, I will tell in the class. But when it is same repetitive, there is no point in again and again writing. You should practice. But still, I decided last time, today, for UDL and point load, I will show the calculation. First, consider point A, shear force at A equal to, come slightly inside, look this side, plus 140.4 kilonewton over. Next, come to point AB over C, D, E. Come to point C. Those who want to write, note. There is point load at C. Therefore, shear force calculation twice. Told, I don't know how many times I told. Start. First, shear force at C just to left of C equal to previous value whatever you got, 140.4. That is the shear force you got just to right. From previous point to this point, in between them, see I told you, when you change the point, you should see what is in between those 2 points. When you change from just to left to just to right, you should see what is at that point. Lastly, I will tell, if you find shear force at a previous point and if you come to a new point, then see or observe what is there, what means what is the loading between those 2 points. Whereas once you find shearing force at a point just to left side, that is only for point load. Then when you go to just to right side, see what is there. So here, after CA up to C, there is UDL, down. From left side, I am seeing, when you see from left side, up is positive, down is negative. Minus 12 into 3 equal to plus 104.4 kilonewton. And shearing force at C just to right of C equal to just to left you got plus 104.4. Then just to left, when you come to just to right, you are considering that side, that is left side, down is negative, so minus 60 equal to plus 44.4 kilonewton. Okay, then after the point C, come to the point D. Right. Shear force at D. 1 minute. Before that, make a note if you want. Again, there is a point load at D. So, shear force calculation twice. First, shear force at D just to left of D equal to previous value plus 44.4. After C till D or between them, there is UDL 12 kN per meter for 3 meter. So, subtract. Why? Now, I should stop this one. From left side, if you consider, if from left side, if you move to right side, then every upward load you have to add, every downward load you have to subtract. So, minus 12 into 3. Some interesting point I will tell you later about this one. Minus 12 into 3 equal to plus 8.4. 1 minute. Last class 57, see, you got some value here. When you reached here, it came negative. So, it crossed the baseline. This time, still it is above baseline. Okay, then, and shear force at D just to right of D equal to plus 8.4. At that point, downward load is there, minus 75. Minus 75 is minus 66.6 kilonewton. Okay, then next point will be E point. Consider E. Okay, now one thing, I write here. Consider E, space problem. E. Again, same note. What note? There is point load at E. Therefore, shear force at E just to left of E equal to previous value minus 66.6 kilonewton. You write below this one. After D up to E, in between, nothing is there. That's all. Stop. And you should write below, here space problem, I am writing this side. And shear force at D or E, sorry, E. Shear force at E just to right of E equal to whatever you got just now, minus 66.6 minus 90 equal to minus 90 equal to minus 156.6 kilonewton. Okay. Then lastly, consider the point B. Come slightly left side. I told you. Look this side. Start. Shear force at B. Previous value minus 156.6. After the previous point till this point, in between, nothing is there. That's all. Now, one check. When you come to just to left of B, if you look right side, see, up 156.6. Shear force is left side upward positive, right side downward positive. So, right up is negative, perfectly tallying. Over. Now, one note you are right, not note, variation. I am not giving. This I have told so many times. I will tell now, you write down. Those who are interested, write it. Interested means dedicated. A to C UDL linear, C to D again UDL linear, D to E constant, E to B constant. The statement you write. Then go back and draw SFD. But I told you to draw SFD, you need not look at any of this calculation. Just take your calculator, start. Start from here. Go up by 140.4. 140.4. Okay. From A up to C, come down by 12 into 3. So 140.4 minus 12 into 3 will give you 104.4. See, just 36 down. That's all. 104.4. When you reach here, suddenly come down by 60. See, here, 60 down. Minus 60 is 44.4. From here up to here, down by 12 into 3. Minus 12 into 3 is 8.4 plus. Very small value. See, sufficient. 8.4. Down by 75. Oh, shearing force diagram is crossing the baseline at a known point. That is where? Exactly at D. That's the advantage of this question. How much? 66.6. 66.6. Then from here to here, no load, go parallel to baseline. Down by 90, minus 90. 156.6 kilometer. 156.6. Then no load, go parallel to baseline. Lastly, go up by 156.6. Just one interesting point. I am not commenting on others, but so many places they will tell you one thing. When there is an upward load is there, shear force diagram jumps. When downward load is there, shear force diagram drops. First of all, diagram is not jumping or dropping. Diagram will remain there only. The ordinate will change. It is not diagram. Okay, no problem. But if you tell that way, see, suppose you draw SFD from this side. See what happens now? Up, down, down, up, down, up. UDL down. Gradually go up, down, up, down, up, up, down. Therefore, such statements I will not use. Telling shear force diagram jumps if load is upward, it drops if load is downward. They should specify then if you start from left side. And also based on sign convention. Why you want all those things? You understand the concept, that's all. Everything will be clear. Same, they will tell, if clockwise moment is there, BMD jumps. If anti-clockwise moment is there, BMD drops. That is from left side. If you do from right side, reverse will take place. So you should tell, when point load is there, shear force will suddenly change. When UDL is there, it will gradually change. That's all required. Okay, leave it. Their choice. Start. I write here 156.6 space problem. Now, shear force diagram over. Now, some note you are write. Observe shear force diagram. Yes, observe. Is shear force diagram crossing the baseline somewhere? Yes. See, at D. Is it a known point or unknown point? Your answer should be, it's a known point. Okay, if it is a known point, I will tell, keep quiet. If it is an unknown point, locate. That was last question. This time known point. Therefore, you are happy that extra calculation is not there. Now, go for bending moment diagram. I just make ready for bending moment diagram, ready for BM calculation. I will calculate in front of you. I already calculated the values here. See, start. Sagging positive. BM at A, 0. This side is okay. Look that side. BM at C, here. Plus 140.4 into 3 minus 12 into 3 into half of 3 is 3 by 2. I will write here. How much? Plus 140.4 into 3 minus 12 into 3 is the total UDL, total load due to UDL into 3 by 2. It will come plus 367.2. Already calculated to save the time. Kilonewton meter. BM at D. Look this side. Plus 156.6 into 4 minus 90 into 2 equal to plus 446.4 kilonewton meter. BM at E plus 156.6 into 2 equal to plus 313.2 Kn meter. Bm at B, look this side, 0. Now, those who are serious should write Bm one more thing. Last time, make a note, we found one more Bm where SFD is crossing the baseline. It was somewhere here between these 2 points, but this time SFD is crossing the baseline exactly at D, therefore that extra point is not there. So the Bm at D itself will be maximum Bm. Okay. Now, variation A to C and C to D because of UDL, parabola of second degree, linear. Write everything and mark all the ordinates somewhat to scale. See, now joining B to E linear 313.2 446. Okay, no problem. Linear. D to E also linear, but slope will be lesser. See? Why? Shear force lesser. Then A to C parabola. Okay, parabola. If I draw a tangent, little more steep, 1 minute. Okay. If I draw a tangent here, the slope should be 104.4. But this side, the slope will reduce 44.4. Here also this side, lesser slope. It will be almost flat, but still parabola. See? Last time, see, it went up, reached the peak and dropped down. This time, will keep on increasing. Okay. It is almost flat. Still, there will be slight slope. Okay, taken care. Okay. There will be very minute slope. See, 8.4. So, it will be like this. Slight slope will be there. Okay, plus. This is the bending moment diagram. These are all the points are explained so thoroughly earlier. If you go through all the classes, by this time, you will almost master this SFD BMD. Other things like like couples, uniformly varying load, overhanging beam, point of contact fracture, cantilevers will come one by one. So, as the course goes on, you see that your level of knowledge keeps on increasing and finally reaches the highest possible level. Okay, thank you. We will meet in next class, class number 59.